Hello, let's continue our advanced Sudoku series with Tiles by Jovial. So this is puzzle number 5 of chapter 4 of the Sudokult Gospel document, which you can find in the description. And as always, I know what technique I'm supposed to use, or the intended technique and how it works, but I don't know where it is in this specific puzzle. And there is a link in the description if you want to try it yourself, and I'm going to get started right now. Okay, let's get as much info as we can here. 2 1s looking down. It's the first thing I saw. Don't know why. 2 6s looking over. Puts a 6 over here. 1 2. So 4 5 8. Okay, 1 4 7. 2, okay, there's really nothing to find here. We don't have like a hidden. Okay, 4 is in one of these two. That's not super helpful. 2 5 6. 2 and 6 might be. Oh, okay, so the sixes look in, and that places the 6. I was right. 6s are interesting. 5 looks up, putting a 5 in one of these two. 2 looks up, putting a 2 in one of these two. Oops, not 0, because 2 is there. This can't be 2 or 5, so it's not 1, 2. It could be 3. It's not 4, 5, 6, 7. It could be 8, 9. Okay. Anything else here? 5, 6, 1. Okay. How about horizontally here? Did I do this? No. 2 8s. There's 8 in one of these two. We have 2 9s, so 9's up here. So these cells aren't 1 8 9. So what are they? They're not 1 2. They could be 3 4. They can't be 5 6. They could be 7. They're not 8 9. That's not a 7. 5 6 8 9. Okay. I think that's it. Looking for more just in case, but all right, vertically here, 2 9s. No, I don't think we're going to get anything in here. Actually, no, we can corner the 9s because they all look into there. So 9's one of those two. And over here, the 8 does get placed. This 9, okay, 5's in one of these two. All right, that's not an 8 now. All right, so these 5s line up, meaning 5's somewhere in here. I don't know if I want to pencil that or not. Am I going to remember that? That's kind of my question. I will put it here because it's non-trivial. I normally wouldn't in an advanced puzzle, corner mark 3, but I will this time. What's that mean for this cell? In fact, we have, yeah, so not the 8, the 4. The 4 is looking down. Oh, yeah, we have something similar going on here. So this is not, see, this could be 1. It's not 2, 3, 4, 5. It could be not 6. It could be 7. Can't be 8, 9. Okay. Okay, is there anything else to find? I'm thinking no. I do need a 4 down here. Oops, I need a 4 down here. I didn't follow up on these 5s either. I need a 5 up here. The 2s, did I follow up on those? I did not. So 2 goes up here. And then here, did they get the 5s? No. So 5's in one of these two. All right. Okay, so we're going to have to look for something a little more advanced now, I think. Do we want to look for restricted cells first? Maybe. Like this cell here sees 2, 3, 4, 5, 8, 9. So it can be 1, not 2, 3, 4, 5. Could be 6, 7. Not a 6, actually. So that's 1, 7. This cell here can't be 1, 2. Could be 3, 4, 5. Can't be 6, 7, 8. Could be 9. Oof. I'll leave it. This one, 1, 2, could be 3, can't be 4, 5, 6, 7, 8, could be 9. Okay, and this cell here, maybe not as limited, because that one wasn't. But it can be 1, 2, can't be 3, 4, could be 5, can't be 6, could be 7, can't be 8, 9. Okay. Do I want to look at these? Are these interesting? 1, 2, 3, 4, 5, 6. Yeah, these are interesting. So 1, not 2, 3, could be 4 or 5, can't be 6, 7, 8, or 9. And this one could be 1, 2, 3, not 3, can be 1, 2, can't be 3, 4, could be 5, can't be 6, 7, 8, 9. All right. I penciled the whole Fisto ring. I don't know if we're supposed to use Fisto ring. Maybe. Let's see what that gets us. So if you haven't seen the Fistmithal ring before, it's kind of the thing that spawned set. So this is the easiest way to prove it. There was a more traditional way to prove it, but specifically for this Fisto ring, this is a lot easier. So what we can do is we can start with these 4 rows. You can also do the columns. It doesn't actually make a difference. We can start with these 4 rows in green here. And so this is 5 rows. This is 5 sets of the digits 1 to 9. Now, notice that box 5 here, we can just remove that. And even though we made this with 5 rows, by removing box 5, we are now 4 sets of the digits 1 to 9. Now what I can do is I can add columns 1, 2, and columns 8, 9. That is also 4 sets of digits 1 to 9. So purple is 4 sets of 1 to 9, green is 4 sets of 1 to 9. And so anywhere that's both purple and green, we can remove. That removes the same digit from both. We don't know which digits we're removing, but we know we're removing the same digit from both. And we still have the equivalence that green and purple are the same. So the 16 digits that go in purple are the same exact 16 digits that go into green. So what does that mean for us? It means I probably should pencil all of these. So let's do that. All right. I'm thinking about taking a shortcut here. 2, 3, 4, 5, 7, 8, 9. This isn't 2, 3, 4, 5. This isn't 4, 5, 9. The 2 is over here, so that's not a 2. Okay. Down here, we need a 1. Can't be 2. 3. Can't be 4, 5. 6, 7. Could be 8. Can't be 9. Over here, we need 1 through 7. This is not 2, 4, 5, 7. This is not 2, 5. Then over here, we need 1, 2, 3, 6, 7, 8, 9. Oh, not the 8. Okay, so 6, 9, 1, 2, 3. All right. Did I miss any corner marks of interest? Yeah, these 4s are corner marks. That's not a 4. Okay. So now what we do is we compare digits. So I like to do that just by removing ones that are in both, just to make it a little bit cleaner to do the count. So we found our 4, we found a 4, do we have a 5? No, so 5 needs to be somewhere, but there's plenty of places for it. 9 and 8 we have, so we'll remove those. 2 and 2 we have. We need 2 5s, actually. Okay, so that's a deduction we could make. Okay, so the first deduction we can make is that there are 2 5s in purple, which means there need to be 2 5s in green. Well, there's only 2 rows that could have 5s in green. So that means there's a 5 in one of these 2, and there's a 5 in one of these 2. And because they can't both be here, that means there is a 5 in one of these 2 as well. So one conclusion is the rest of this row can't be 5. So let's just pencil it. 1, 2, 3, can't be 4, 5, 6, 7, 9. Okay. That's not a 2. Also, the rest of this row can't be 5. So 1 can't be 2, 3, 4 can't be 5, can't be 6, 7, and 9, because it can't be 8. All right, 1, 1, 4, and 4. Okay, so that's our first conclusion. Whether that's helpful or not, I'm not sure. We already had the pointing 5s here, so I doubt that was helpful. We can also try to put green into purple. So green has 3, 6, 7, 8 in it. So we need to put 3, 6, 7, 8 somewhere. I'm not convinced this is the set we were supposed to use. One of each of 3, 6, 7, 8. Now the problem is we have like 2 degrees of freedom here. And I'm not seeing a significant restriction on them. So I think I used the wrong set. I might have to look for another one. Okay, so the other possibility that I was thinking about is, oh wow, I wasn't in the right mode. That was terrible. Okay, now I'm in the right mode. The other option I was thinking about is these are quite diagonally, like they're all the givens are on, almost all the givens are on the same checkerboard tiles. Maybe that's why it's called tiles. So we probably want to pick a checkerboard set. We want to pick one that's going to include, let's see, let's just look at this one first. This checkerboard set here. What would this get? Let's make this green. This gets 1, 5, 6, 7, 8, 9. So really it's what, like 2, 3, and 4 that are missing? So yeah, can we capture 2, 3s, and 4s by doing this? It looks like we can, quite a few of them. It would be these to capture 2, 3, 4s. So we're going to do 5 verse 5. Maybe we'll do 5 verse 5 and see how that goes. Okay. So this is 5 rows, 5 columns, and then anything that's doubled up we can remove. So these will be exactly equivalent. There's not a imbalance in this set. Hopefully it's the right one to use. So now we need to. I think I'm going to do the similar eliminations again, just to keep it clean. Are there any similar eliminations? Interesting. Okay, well, let's count up. So empty cells, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 empty cells. And how many filled cells are in purple? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I must have some doubled up digits. Where are my doubled up digits? Well, let's think about it this way. Green covers, let's see, 1, 3, 5, 7, 9. That's it. So it's the odd digits. Okay. So yeah, so I can get rid of, so green is the odd digits, purple is the even digits. How many even, so there are no even digits in green yet. Sorry, there's another 9 down there. So how many even digits do we need? We need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is a 0 degree of freedom set. Very traditional set. So because there are 10 even digits in purple and none of them are accounted for in green, we need the remaining 10 green cells to be even only. 2, 4, 6, 8. And we clean that up a bit. Oopsie. 4, 8, 2, 8, 2, 8, 8, 2, 6. Okay. And then additionally, we can send that back. So there are the rest of these should have to be odd because we can't fit any more evens into green. So these are all going to end up odd. 1, 3, 5, 7, 9. Okay. And none of these are 9. Interesting. So that's not 7. That's not 3. Okay. Right. And so had we gotten rid of these 9s, we'd have seen that 9 was irrelevant to all of this, but that's fine. So that's our set. I don't think I need the colors anymore. Let's not track it as we go on this one. 2, 8 pair, so this is not an 8. 4, 6 pair, so this is not a 6. What else do we have here? Now we just have to scan this properly. So it's so notated at this point. Let's see, what do we need? This is this is almost a 1, 2, 3. Okay. 4 and 5 over here. 6, 7. That doesn't help me. 4, 6 pair, 2, 8 pair. We have all our evens here. So, oh wait, we need a 9 in this row. Oh, the 9 can be in 2 places. This is 1, 3. Oh, sorry, it's not 3. 1, 5, 9, because it can't be 3, 7. It's only odds. Maybe I should odd even color. Would that help? That might help actually. Any cell that's only even, I'll make blue, and any given that's even, I'll make blue, because we need 4 even. We need 4 blues in every row column box, and then we're going to need 4 oranges in every row column box. These are only odd. That's only odd. That's only odd. This one. This one. 4, 8's only even. 3, 9's only odd. 1, 3, 7, 9's only odd. This is only odd. Okay, what have we learned? Anything else? This is odd. This one's odd. So I have all of my evens here. Yeah, sorry, these givens are all odd. Let's do that. All right, that's helpful. So we have all our evens here. These two are odd, so they're from 3, 5, 9. Okay. We need an 8 in this column, actually. Yeah, this has to be blue, so this is 8. Nice, this is helping. So we get the 1 and the 9 here. This is not an 8. Why would I mark that odd if it could have been 8? Hold on, that's a mistake. The mistake was that I marked this as odd at some point. Okay. 8 could be in 2 places. Whoops. 2, 4, 6 is even. 2, 6 is even. 1, 5, 7 is odd. Right, anything else? So one of these is 8. This box is all odd. So 1, 5, 7. This not help. Oh man. If you color it wrong, it helps. Wait, get rid of these corner marks. Get rid of these corner marks. These 5s maybe are helpful. We'll keep those. This is 1 even and 1 odd. Right. 1, 3, 5. Yeah. Doesn't really help. Oh, these 9s look in. There we go. And now we know these are even. So the 9 has to go here. That's important. So, oh yeah, this 9 had a corner mark in a blue cell. Whoops. That's 3. That's 5. That's 9. We get the 7. We get the 3. We get 1, 7, and 5. That's not 9, so the 9 goes there. Do I clean up now, or is there more singles? This is an 8. That's blue. That means that this is orange, and it's a 1. That's 7. We get the 3. We get the 1. That's a 2, which is even. That's a 5 and a 6, so this is odd and this is even. Yeah, this is the last even, and this is odd. And it's a 7. We get our 4 and our 3. That's odd, that's even. This is a 9, which is odd. I think it's all singles. We get the 1, we get the 7, we get the 9, the 3. I'm just plonking. All right. We're cleaning up. Okay, so that's an 8. We get the 1, which is odd. These aren't 3 7s. We get the 5 here. We get the 1 and the 5. We get the 1. Here we need, this one needs to be blue, and it's a 6. Whoopsie. It's a 6. These aren't 6. This is a pair. What is it? 2 and 3. Okay, we know the order. That's 3, that's 2. That's blue, that's orange. Okay, what have we learned here? These are both orange, so this has to be blue. And it's 2 or 6, can't be 6, so that's 2, 6. It places the 2 here. I need an 8 in this row, and I need a 5 in this row. 5, 8. Okay, this can't be the 8. Sorry, I missed that. So that's orange, that's blue. This is 8 and 5. You get the 4 and the 5. That's blue, that's orange. These aren't 8. I need a 7, and I need a 4. Okay, so that's 7, that's 4. And then I need a 6. What is this pair? It's 6 and 7. So this is the 6, this is the 7. Color those. This gets colored orange. This gets colored blue. So our colors are done. This last orange is a 3, and this last blue is an 8. Nice. All right, well, I don't know if even odd helped, but I mean, basically, as soon as we applied the correct checkerboard set, which I should have thought of that. We had so much info in the Fisto ring. I thought maybe the Fisto ring would be it, but no, it was the it was the checkerboard set, and figured out the correct one to start out. So that's nice. So yeah, just only odds in one set, only evens in the other. And so they had to, and it was 0 degrees of freedom, so they had to transpose into each other. So a very, very straightforward, common use of set there without any degrees of freedom. So a nice breath of fresh air from that after all the ones ones with degrees of freedom that you had to do an exoset logic for, or fins or things like that. So hope you enjoyed this. I did. If you did, then why don't leave a like, subscribe, and a kind comment below.